promise of AI powered coding tools is attractive. Press a button, get an instant code. But here's the uncomfortable truth: writing code was never the bottleneck. The real challenge, and the one AI hasn't solved, is building the mental model that lets you truly understand what you're looking at. Hello, everyone. Welcome to the Analytics Insight podcast, where we talk about the ever evolving tech space. And I'm your host, Priya Dayalani. Large language models like Copilot are transforming the entire software development lifecycle. They are no longer just auto completing code, they are generating features, debugging complex issues, and even performing code reviews. But there's a secret to unlocking this power, and it goes far beyond a simple prompt. It's context engineering. Joining us today is Amar Goel, co-founder and CEO of Bito, to talk why understanding a code bases is not just about writing code. I think it is the next frontier for AI. Hi Amar, how are you doing?
Hi, Priya. Great to be here, and yeah, I'm doing good.
Great. Likewise, it's a pleasure to have you on a podcast today. And I think we have been having a lot of debates around, generative AI coming into picture, agentic AI coming into picture, and, their impact on the software development life cycle, on the role of software engineers. And there's a lot of bubble happening around it. So I think we are going to debug a lot of myths and understand, what exactly the core issue is, and also probably how does the future look like. So let's start by telling our listeners more about Bito. We want to understand about the company, its specialization, and along with that, we would also like to know more about you, Amar, your journey till date, and your role towards the company currently.
Yeah, so I'm CEO and co-founder of Bito, and Bito, we are really focused on building agents and tools for software development teams. And what we believe and what we have been really focused on is that we think that the context, and you were kind of mentioning context engineering, context is really, really critical to writing and developing high quality software, with Gen AI. And so I think if you take a step back and you say, hey, Gen AI is kind of redoing the software development life cycle and changing how all software is developed, and it started to do that for sure, but I think the changes will be much bigger over the coming years. One is, of course, the quality of the models matters a lot, right? The more intelligent the model is, the better the job it will do at understanding your prompt and being able to kind of think through what it needs to do. But at the same point, we're also finding that the context that you provide the model, the context that you provide the task that you're trying to do, has a huge impact on the quality of that output. And I think in some ways that has been like an under leveraged and underexplored opportunity to improve like how powerful Gen AI, the impact of Gen AI can be for a development team. And so what I mean about context is, on one hand, you could say, oh, there are things that people are starting to get well known about, like, oh, my context window is only so long, right? I can only fit 50,000 tokens or 75,000 tokens, into my context window, into my chat window before I need to like start over. But so then you could, of course, say, what's the question of like, hey, what is in that chat? What is the 50,000 tokens you want to include? But I think if you think about a medium or large size engineering team, context is a lot more than just, hey, what am I putting in that single chat? It's like, does it understand how your system works? Does it understand your architecture and design patterns? Does it understand, hey, how do you actually call your billing service? And that your billing system is actually 4 different services with 20 different endpoints, and how do you orchestrate that? So I think there's a lot that comes into, and that, oh, this part of the code base has been having some stability issues because we keep having to ship hot fixes. So if you're going to write some code touching this area, you need to take that into account, right? All those things have a huge impact on the quality of the answers and the output you're going to provide. So those are kind of the problems that we are focused on.
Great.
I don't know.
Glad to
It was
know.
a long answer.
Yeah. No, that's fine. I think that was pretty much comprehensive and definitely sets the foundation for our conversation moving ahead. And I think I'm really glad to see how the company is carving a niche in such a dynamic and competitive landscape. Great. So, we have tools like Copilot and Amazon Code Whisperer and so many other numerous tools. And I think they have changed how we interact with code. And while they are undeniably helpful, especially for repetitive tasks or boilerplate, they also shift the responsibilities because developers today no longer start from scratch. They are dropped into halfway done logic that someone or something else wrote, like an AI agent. So that changes everything. Reviewing code you didn't write is cognitively harder. Spotting silent bugs or deprecated patterns takes more focus, not less. And while junior engineers might enjoy faster results, they often skip critical learning in the process. What we gain in speed, we might pay for in oversight. So, for decades, software development focused on writing code. Why is the industry suddenly realizing that understanding code bases may be the bigger challenge?
Yeah. Well, I mean, I would sort of argue that, I mean, I don't know that only focused on writing code. I mean, I actually think that writing code was sort of the output, but I think a lot of the focus has been on designing good systems, and good design, good architecture, systems that can scale, that are resilient, right? That are take into account future requirements or, future ways that you might want to extend it. So I think that has been one really important kind of core competency in designing, scalable software systems. But then I think I would agree with you that, the other big part was like churning out the code that, followed those principles and practices we just talked about, around architecture and design. But yeah, then writing, a lot of manpower went into building the actual bridge, right? Writing the actual code. And I think that part AI is starting to help with quite a bit, right? So I think teams are saying, hey, instead of being able to do one story point now in a day, and write maybe 100 lines of code, now I could maybe write 500 or 1,000 lines of code, in a day. But I think, like you said, there still is a lot of issues that happen around that, which is, okay, I didn't write this code. Do I really understand what the AI did at the same level that used to happen when I had written the code? And then certainly if I hand it over to somebody else, can I explain it to them when they're doing a code review or something like that? We have an agent that helps with code reviews as well, because, again, we believe that we are trying to deeply understand your code. But I do think the bottleneck is starting to shift, upstream, which is like, how quickly can we design and scale, the system, right? And so that is an area where I think senior engineers, architects, that typically, if you look at a sprint, 20-ish% of time is going into that planning and designing. Like, I have a PRD, I have an epic, I have an important story. How do I think about, the feasibility analysis, scoping, estimation, task breakdown, work stream breakdown? I mean, all of those things are where your kind of most valuable engineers spend their time. I talk to lots of leads who say, yeah, actually 90% of my time is actually trying to make sure we design this thing right. And the reason that that matters is, I mean, if I'm building a bridge and I didn't think through correctly, what kind of load is this bridge going to need to bear? What materials, is it suitable for the environment? Are people going to be walking on the bridge? All that stuff. If I don't think through that properly and we just start building and writing the code, building the bridge, then 6 months later, we're going to say, hey, we have a bridge, but it doesn't do what it was supposed to do. I mean, it doesn't, heavy trucks coming on this bridge now, and we just designed it for cars, and so now this bridge is going to break, right? And so those are the kinds of things that, architects and senior engineers spend their time doing. And I think that is still really critical. And I don't think AI has been able to help with that, very much so far. We've built this kind of AI architect agent that we think really, because it has a broader, deeper understanding of your code base, develops an understanding of how your whole code base is working together, builds a graph of it all, can actually help with that. And we think that is a really important part of this move to agentic coding. And I can talk more about that if you think would be helpful.
Yeah, sure, Amar. I mean, we would like to gain more insights if there's something particular you would want to share.
Yeah. So, I think there is increasingly this idea that, we can more and more automate the software development process, right? So we can go from, I've seen multiple teams now showing me like kind of a harness they've set up where they're saying, hey, I can drop a Jira ticket in and it will take a Jira ticket or take that PRD and go all the way to a PR, right? A pull request. So trying to automate that entire process in between of, hey, planning out what we need to do, writing the code, and then, moving to like a review, process. And so I don't think anyone's doing it for huge features yet, but I think teams are starting to experiment with that and get to that for small and medium-sized, features and or bugs. And you may, of course, have a human in the loop, and nobody's saying there's no human in the loop useful, right? At different stages, you can say, human, can you review what the AI has done and iterate with AI to like improve it? Maybe it builds a plan and you say, hey, you missed this, or well, that's an interesting idea, but can we add this piece in or whatever, right? And so then, in a couple of loops, you may end up then with a better outcome that then the AI could go start writing the code. So if you think about that kind of move to a fully agentic process, that typically that upfront stages is where humans still have to spend a lot of time, because once some ticket comes in that says, hey, let's build this bridge, or we want to add a second story to this bridge, then all of a sudden it's like, well, humans are the ones who have that map of your code base in their head and say, hey, which capabilities do we already have that we can leverage today? Which things do we have that we need to extend? What's totally new that we need to build from scratch? And where should that be housed? So, I mean, that's where humans add a lot of value today. And what we're finding is teams are saying, hey, with Bito's AI architect, that can help augment what those humans are doing. It can provide a first pass on a lot of that analysis. And what might have taken a senior engineer 15 or 20 hours to get done, in half an hour, they can have a decent first pass done with AI. And in an hour or two, they can have a 90%, after they iterate with the AI a little bit, right? And so I think that's what we're seeing is as teams are saying that this is a big unlock for us, because now this bottleneck is being removed and the whole process can move much, much faster. Where AI can really shine is where it's not just helping you do things faster, but I think in some cases it's helping do things at a higher quality, because you're able to do things now that you couldn't do before, right? So now that's where it's one thing I would think, I think a lot of times teams would say we didn't have time, to actually do a detailed analysis here because we're trying to move fast. So some engineers just kind of started working on it. But now if you insert, some agent in there, in 20 minutes, it can say, hey, yeah, or 5 minutes, it can say, hey, I did a detailed analysis for you that before because it was going to take 2 days, you didn't have time to go do. But now you're like, hey, I have a detailed analysis that was done that told me about what's the best ways to approach this or some potential landmines. So I think that all of a sudden is improving the overall output, but also helping you do it in a faster way.
Yeah, definitely. That's a fascinating perspective, Amar. And I think it kinds of reframe how we look at software development today. And I think as systems have scaled, what we are really seeing is a shift from creation to comprehension. And I think it's getting more amplified in the age of current AI.
Yeah, absolutely agree.
Right. And so, in the world of software engineering, I think system architecture is the bedrock upon which every successful application is built. It dictates how components interact, how data flows, how the system scales, performs, and even tackles the failure. For decades, this discipline has been a human centric endeavor where you have a blend of experience, established patterns, and also painstaking manual effort. Because architects would spend countless hours on whiteboards and drafting diagrams and documenting decisions. However, the complexity of modern software has pushed these traditional methods to their limits, because now we have microservices, distributed systems, serverless computing, and the constant pressure to deliver faster has created an architectural landscape of unprecedented intricacy. So, how does AI architect map relationships across APIs, services, and the overall architecture to create a system level view?
Yeah, so what the architect does is it goes through your entire code base. It goes through repository by repository, and it really learns like, hey, what are the different services I have? Understands semantically, like understands like what is this actually doing? Okay, this is a service about billing, and these are the different capabilities it has. This is how it works. These are the different endpoints, that are available. And so then it's trying to understand as well, like what are the architecture and design patterns that you have out there. And so, like what are the different, oh, here we use a factory pattern, or, we use Axios to call HTTP rather than, calling it directly. So it understands like how your team, does things in terms of what your, like I said, your architecture and design patterns are. And then importantly, it builds a graph of how everything connects together, right? So it understands this function calls this function, which then calls this function. So you then can understand things like, hey, if I wanted to upgrade Kafka, what are all the different consumers or APIs, or services that would be affected, and which versions are they all on, and which ones would potentially break if I went from this version to that version, right? So it can understand across your system, questions like that. Or if you're trying to explain to somebody, hey, we have a, authentication system, like how does that work? Because it understands how it's all connected together, it can provide a very cohesive explanation, to a company. Let's say if I'm running, I run an e-commerce website and you're saying, hey, when somebody like puts something in their cart, can you explain to me all the different systems that are touched, right? Oh, well, we have some data that first goes to our analytics system that tracks what this user added to their cart, and then it's also updating our inventory system, and it's also doing this. So it understands how all of those components are connected together and how everything is being impacted. So you can use that to help either learn a system if you in a company, or some new person can use that. But when you come to that kind of that piece around how a senior engineer can use it, it's now a lot of times you're, like I said, you're building a new feature, or you have some capability you're trying to add to your platform, or you're trying to figure out how a bug is happening. Because it understands how all the system is connected together, it's able to share with you that these are the different APIs that you could potentially use. This is what's connected to this. This is how data or calls are flowing through your system. And so this is the impact that something upstream or downstream, may be happening. So I think that is really, where you can really have a big impact with this, with the architect. I don't know if that's
Definitely.
helpful.
Yes, yes, Amar. And I think once you step back and look at the bigger picture, what really stands out is how AI is no longer just assisting at the component level. It's kind of comprehending the entire architecture itself. And I think this ability to map relationships across different verticals is transforming AI from a coding assistant to a true architectural partner.
Yeah, absolutely. No, I totally agree with that.
Yeah. And moving ahead, I think when we talk about AI, today's world is based on data, and AI is drowning in unorganized data. Sometimes it's really hard to understand, the context, connections, and meaning. And that's when knowledge graphs come in handy. So what they do is they take these raw broken data and turn it into an organized web of linked data, which is similar to how people see the world. So, this concept of living knowledge graph for software systems is gaining pretty much attention nowadays. How does this change the way teams navigate and understand large code bases?
Yeah, I mean, I think, as I was kind of mentioning, like the issue I think is that to move at like an agentic pace, you need this deep kind of system level understanding, right? Because in a large code base, in today's kind of software, they're all very interconnected systems. You don't just have like one service that you're changing or one component that you're changing. There oftentimes are many services being touched when you're building a new, capability or feature. And, one change here can affect some things, potentially downstream or upstream from that. And so this is where those architects, and senior engineers really come into play, because they understand how the whole system fits together. They understand that the impact of this one change on another part of the system. And they understand, one of the big issues that a lot of development teams have is they're like, hey, we have built all this functionality that we want to reuse, right? We don't want to, let's say I have some capability to add a new user to our system. I'm just kind of giving a simple example. Well, if somebody else somewhere else in the code base says, I want to add a new user, we don't want you to rewrite that and add a new user functionality. We want to use the functionality that we already have. Otherwise, we end up with 14 different versions of adding a new user. And then later on, when we're trying to do some upgrade or make some change, now we have to go and change it in 14 different places, And if each one of them is done differently, we can end up with, subtle bugs or, differences in how users are being added. And that's like a very core thing. So we want, one function, one class, one method that says, hey, add a user, delete a user. But a developer may not know where that is. So they may just write their own, add a new user. But that architect will say, hey, we have a whole library that's built for us to add a new user. And they have that map in their head and they have that understanding. And so those kinds of things I think are really critical for large scale code bases. I mean, you talk to some teams that'll say, hey, we have 200 microservices. We have 1,000 different components. We have 5,000 different, talk to one engineering team that's saying we have 5,000 different services out there. So how do we have something that really understands across these 5,000 services so that we do reuse that code and don't just kind of end up writing 5,001, 5,002, 5,500 that are just recreating things that we already had?
Right, Amar, and I think it almost feels like we are moving away from traditional documentation, which is, of course, very much outdated, towards a system where context is continuously evolving and self-updating. I think, I think it will significantly reduce the onboarding time and make cross-team collaboration far more seamless.
Absolutely.
Great. So building on that, Amar, we discussed the entire, I would say, the landscape of software development from a leader's perspective. My next question is something that, I've asked this to a couple of leaders, but I would like to gain insights from your end as well. We discussed how AI is changing software development, and of course, it's kind of changing the roles of developers as well. Now, I came across this study which shows that AI helps people do parts of their job faster. And in another study, we found that AI can speed up some tasks by 80%. But does this increased productivity come with trade-offs? To answer that, there was this another research shows that when people use AI assistants, they become less engaged with their work and reduce the effort they put into doing it. In other words, they offload their thinking to AI. So it's unclear whether this cognitive offloading can prevent people from growing their skills on their job, or in the case of coding, understanding the systems they are building. So if AI becomes very much better at writing codes than humans, what do you think would be the role of developer today and in the coming years?
Yeah, I mean, it's a good, good question. I think there's so much different research that's coming, out about, are these tools helping? Are they hurting? Are they moving the bottleneck? So I think, it, it can get uh, really, confusing, if you will. I think broadly what I would say is that, there's more and more intelligence that's available, right? AI is providing intelligence, at an improving rate, and the cost of that intelligence is going down, right? Yeah, last year, if you were to, let's say, ask a model of, one of the frontier models and ask it a question, that may have cost you 50 cents, or let's say that cost you $1 for some analysis that it did. Well, today that same, analysis, that same level of intelligence is available for maybe, 1/5 the price, right? So it's come down, by, 80%. And next year it'll probably go down, another 80%. So I think for a given level of unit of intelligence, the price of that is dropping, at a pretty fast pace. Of course, people are trying to stay on the latest models because they want the most, intelligence possible. But I think the overall point is that intelligence, the price of intelligence is going down and intelligence is becoming, abundant. So that's kind of one, high level comment. I think, then a lot of that value goes to things like what people are calling taste now, right? Like what should we build? How should we build it? Does it understand our context, our situation, right? And those are things that I think not some of those things models can help with, but some of those things models can't really help with, like exactly understanding what it is you want to build. That's kind of a different, thing. And again, you can use a model to help you do that, but eventually, like somebody has to understand what it is that the customer needs, right? And so, what is your own vision of what you want to build? So that's where, I think humans can play a very strong role, which is like, hey, what is the product and the capability that we want to tell the AI, to build? And then, we get to the point I was making earlier about like, well, how do we want to build this bridge? Because, what is the long-term goal of this bridge, right? Are we going to make it out of brick because it looks pretty? Or are we making it out of concrete because it can bear more weight, right? Those are things that, again, AI can help you think through that. But, at the end of the day, that's kind of humans call and humans decision making around like what is the purpose of this bridge overall. So I think those are areas where I think for quite a while still humans are going to have an important role to play to guide AI to get what it wants. I mean, this is like a very high level comment, but like, AI is in some ways providing that next level of abstraction when it comes to software development, right? People used to write in assembly code, then they went to, like more human readable languages. Now English, the new, kind of coding language.
Right, definitely. And I think, while AI can generate lines of code, it still takes human judgment to define the problem correctly or to ask the right questions and to also ensure what's being built actually makes sense in a real world context. Great. So I think the future of software development involves structuring the project not only for human readability, but also for the AI comprehension. And having said that, Amar, one last question to wrap up our conversation is if you had to summarize the next frontier of AI in software engineering in one sentence, what would it be? I'm sorry to put up across this as to put up your answer in one sentence because I'm sure it must be challenging, but I thought probably just make it more interesting.
Uh, I think what I would say is that software engineering is going to go through a very dramatic set of changes that is going to result in dramatically more software being written in the world, created and written. I think the amount of output is going to go up 10x over the next few years. But how that software is being created is going to, like I said, change very dramatically. And, where humans and AI are going to mix together, I think is still very much evolving and frankly, like a little hard to completely forecast.
Definitely. And I think in the AI era, software engineers are moving from mere execution to judgment. Instead of asking, how do I write this code? We must now ask, is this the right thing to build? Is this the right architecture for our long-term goals? Or, what could break in production that AI hasn't seen yet? AI can definitely generate solutions, but it doesn't understand consequences. And that responsibility still belongs to us. So I think AI is no longer just a coding assistant. It's more like a strategic partner in your software architecture. By integrating AI insights into architectural planning, organizations can build software that is robust, scalable, and future proof. Thank you so much, Amar, for taking out the time and efforts and helping us understand that with the evolving role of AI and its integration in the software development, we need engineers who know when not to delegate, who understand how AI tools work and where they break, who can explain not just what a system does, but why it does it. And I think AI changes how we build software, but the responsibility to build it well, that's entirely humans. Thank you so much, Amar, for your insights. It was lovely chatting with you.
Yeah, great. Nice to talk to you, Priya, too. Thanks so much for having me.
Thank you so much. So, this is for our listeners. I hope you enjoy today's discussion around software development, software architecture, and as AI continues to evolve, software architects who embrace it will gain a competitive advantage, delivering high quality applications faster and more efficiently. Stay tuned for upcoming episodes, and you can view all our previous episodes on Spotify and other leading platforms. Thank you so much.